This is the offset guide block version 2. What is the print trying to tell us? The first thing we want to look at, of course, is our title box. And that's going to give us who made it, what it's called, and especially things like tolerances and special instructions. The next thing we want to look at are notes. And looking at two things, we have some special things here. One, line drill after welding. Break all edges, remove all spatter, check dimensions after welding. If we look down in the title box, it says weld sizes are minimum acceptable size. Now the line drill after welding and the weld sizes are minimum will affect things further down in the build, and we will see those later on. So looking at the print, we want to see what kind of things we need to be aware of. In the lower right, looking at the right-hand side view, you can see that the measurement of 1.5 inches clearly denotes that something goes in there. So we want to make sure that this distance does not change from the beginning to after we weld it out. So that's something we keep an eye on throughout this build. There are other instructions on here besides welding instructions, and these have to do with drilling the holes. So if we look at the print, up at the top it says 1/2 inch diameter, 2 places, and through. And what that is telling you is that symbol with the line with the arrow going down and through means go all the way through the part. Now if you were not going through the part, this would tell you how deep the hole is. Next we have 5/8 diameter line drill and through. And in that case, line drill is telling you that they want the holes drilled from one to the other all the way through the part. And that's demonstrated by the dotted line with the arrow. And we'll have it set up at the end and show you what that looks like. The location of the holes needs to be found by carefully reading what information they're giving us. Again, reading the print and trying to see what it's trying to tell us. So when looking at the top side view, the location of two holes, the hole on the left says it's 3/4 from the end, but then if you look at the other hole on the right side, there was no information given from how far it is from the end of the part. But what we are given is the measurement between the holes. So clearly that's telling us that the dimension from the end of the part through to both holes is critical, and that the end part where there is no measurement is not critical. So that's what we want to use to figure out what that measurement is. Looking at the weld symbols that we're going to be using here, we can see that they're just ordinary 1/4 inch fillet welds, and that they're both a 1/4 inch long, but the instructions are that the welds are minimum acceptable size. So in reality, that weld needs to be bigger than a 1/4 inch to be the acceptable strength. So if you did do a 1/4 inch weld, even if it were perfect with no defects whatsoever, it would fail because it is below the accepted size. So the reality is your weld needs to be like 5/16 or larger in order to be an acceptable minimum strength weld. The other type of weld that is being used on this build is a U-groove. And you can see that the symbol is that sort of upside down U, and it also has a straight line contour symbol. What it's telling you is once a U-groove is ground into the part and welded, that the surface needs to be left flat. And since there is no process designation like a G for grind or M for machine, you'd use whatever process is most convenient to you. And in this case, we can use our grinders. A very important aspect of this part is learning to orient the part so that we can work on it in the most optimum position possible. If we left the part on the table to do the fillet welds, as you can see, the outside is easily accessible, but yet the inside, you're not going to be able to get in there because the other wall gets in the way. So you need to do some careful thinking to orient the part so that every single weld, every single hole that needs to be drilled is easily accessible and doesn't require some kind of gymnastics to be able to get done. Because the harder it is to do, the greater likelihood of mistakes and errors along the way. In this picture, the part has been tilted enough so that you can see that both inside and outside are clearly accessible when coming straight down. So you can see here, if you just orient the part a little bit, tilt it one way, tilt the other, both sets of welds to be done are clearly open and accessible. So whenever you're setting a part up, move the part and try and figure out in which way you can easily get in, and then clamp or fix the part so it stays there without moving while you're working on it. Here's a picture of the completed part, just like it is in the auxiliary view on the print itself. You can clearly see the welds inside and out, the hole through the part, and even the hole in the base of the part way over on the left. Here's a close-up view of one of the outside welds, and you can clearly see that the weld is aligned right along the weld axis evenly on both sides, and that the size of the weld is consistent from start to finish all the way across. To figure out if your welds meet the acceptable size, we need to use weld gauges. So here a 1/4" weld gauge is used. Make sure it's resting flat on the face so that the leg rises up and meets the weld nice and solidly. You can see by the green line that the weld exceeds the minimum 1/4" required, so this weld is perfectly acceptable. Even though the instructions for welding say that the 1/4" weld size is a minimum and there are no maximums, there actually are practical limitations of how big you can go. And this is a really good example. Looking down at the part, the holes on the inside, the 1/2" holes, you can see that where the green ring is, there is nothing welded there because I'm leaving space for a bolt or a washer to be put in place. So if the welds were larger than that, there would be no way to put the fastener that obviously must go in its place. So even though there are no minimums to the welds, there are indeed maximums, and those are based on practical considerations of how the part is to be used, what it's attached to, and things that might get in the way. And these need to be found out through carefully looking at the print and trying to understand what is it used for and what is it meant to do. Looking at the completed part from the end, you can see that on the right side that the upright is 90 degrees to the base and is in the correct orientation. But if you look at the left, maybe through too much weld, too much heat, the part warped and is now tilted inwards slightly. And we can see that this is going to cause us some problems. So if the print says this part must be 90 degrees, we need to do our very best to ensure that the part remains in the proper orientation to each other throughout the entire build. The instructions on the print were line drill after welding, so these two holes need to be drilled all at the same time. Now looking at the part, the red part is how it is actually tilted and it's pointing towards the hole. The green is how it should be oriented, 90 degrees to the base with the hole 90 degrees straight across parallel to the base. And you can see that it does not hit the hole directly but is way off to the edge. So you can see that that error now makes drilling the holes accurately impossible. Here's another view of that hole from the end. Now, the red X is the center of both holes, but the reality is the actual center from the other hole to the one on the outside is where the green arrow is, that center punch mark. So you can see how far off they are. Because the other side is tilted, that hole is now completely where it should not be, and this part is not usable. Even though the welds are correct and everything else is good, because one part is tilted, it has rendered the part useless. On the drill press, I've set up a right angle plate and some other parts and clamps in order to securely hold down the part for line drilling. The numbers under 1, 2, 3 are for the clamps. There's a bolt in the base of the angle block. There's a clamp on the left and a clamp on the right to hold all the parts as securely as possible. Every time you're going to drill or grind or work on a part, it must be held with as many clamps as necessary in order to fix that part in space. Here's a view of the end to give a better view of the bolt going to the T-slot in the base of the table. Here's a close-up view of the setup, and you can see the previously drilled hole that used just the table vise versus the angle block setup. You can see how off the holes are. The red line going through the center of the drill bit is way off on the edge of the hole below, which we saw in the earlier photographs. Epilogue, what have we learned? First, reading the print will show the best point to begin the build. Errors in the beginning can have unexpected effects later, as we saw that upright that tilted a bit from welding completely threw off the drilling all the way through the build and made the part unusable. This could have been corrected had the part been tacked and then carefully braced before welding so it would prevent the part from moving, and then once the part was cold, the braces removed, and that would have eliminated that problem entirely. And there are practical limits that are unstated but need to be found. Like if the weld says there are minimums and no maximums, there definitely are maximum limits that are based on practical necessities of the part. So you need to read the print carefully, look at what it needs to do in order to find out what these limits are. Even though they are unstated, there definitely are limits in there. You might call it reading between the lines of the print for information.